Hello everyone and welcome to Yebo Physics on a Thursday afternoon. I hope I find you well. It's good to realize that I've got some company here on Teams. I hope many more people are going to join. I can see also I've got a few people joining on the live stream on YouTube. Welcome. I hope you will interact with me as we solve these few problems that I have, and we hope that we do this together. So I have questions on current and resistance. So it's going to be the second follow-up session from the first session which was held last week. So we want to look at calculations that involve current and resistance, which I believe it's a topic that you have covered. So feel free to ask questions as we go along the tutorial. If you're joining live on the Teams platform, please confirm if I'm audible. You can just react by a thumb just to confirm that I'm audible. Any one of the people on Teams who can confirm that I'm audible? All right, thank you. Thank you, Machazi, for confirming. So already I'm showing a question. We'll get straight to the questions. The question that we are showing here reads that 5 joule, let me see, I think I'm not showing the full question. Let me just scroll up a little bit. All right, so that's the full question. So it reads 5 joule of work is done in moving 12.5 times 10 to the power of 18 electrons from one end to the other end of a conductor. What is the potential difference between the two ends of a conductor? So what is the potential difference between the two ends of the conductor? Remember, by definition, potential difference is the work done in moving a point charge from one point to another. So writing down what we have, so this is question 11. So we're told that the work done, which is W, is equals to 5 joules. And what else are we given? We're given the number of electrons, N, which is 12.5 times 10 to the power of 18. So that's the number of electrons. But what we already know, potential difference V is equals to the work done per unit charge. But the total charge Q is equals to the number of electrons present multiplied by the elementary charge, which is the charge of an electron. You should recall that E is equals to 1.6 times 10 to the power of negative 19 coulombs. So which means that our equation then becomes V equals to work done over NE. Now the work done we're given, it's 5 joules over Qn, which is Ne, which is 12.5 times 10 to the power of 18 multiplied by the charge of an electron, which is 1.6 times 10 to the negative 19 coulombs. Then obviously you can punch this can punch this in your calculator. If you have your calculator close by, you can confirm if you get the same answer. 12.5 times 10 to the power of 18 multiplied by 1.6 times 10 to the power of negative 19, you get 2.5 volts as your potential difference. So you can see you've got an option that gives you 2.5. So basically that's how you would work out this problem. So if you look at this problem, the main thing that you're supposed to recall here is the equation, knowing the definition of potential difference as the work done in moving a unit charge between any 2 points. But obviously you're not given the total charge, so to find the total charge on that conductor will be to multiply the number of electrons by the elementary charge of an electron, which is 1.6 times 10 to the power of negative 19. Then once you do that, you substitute to your equation, and this is what you would eventually get. So that's how we've solved the first question. So I hope that one is clear to all of us. So I would like us to move on to the next question, which is question 12. Question 12 reads, a well-insulated electric water heater connected to a 240 volts potential difference warms 109 kilograms of water from 20 degrees Celsius to 49 degrees Celsius in 25 minutes. What is the resistance of its heating element? Use the specific heat capacity of water is that. So in this question we're being asked to find resistance, but we're given a couple of things. We're given the rating 240 volts. The electric heater is connected to 240 volts, so our V is 240 volts. That's the potential difference. We are given the mass of the water, which is 109 kilograms. What else are we given? We're given the temperature, initial temperature, which is 20 degrees Celsius. Then we're given the T final, which is 49 degrees Celsius. So temperature did increase. And we're also given the time taken, which is equal to 25 minutes. All right, 25 minutes. What is the resistance of its heating element? So we need the resistance of this heating element, because remember what makes the water hot, it's because there's a current flowing through this wire heating element of high resistance. So that current will result in a heating effect, and that heat is being transferred to the water. So from what we're given here, it means we should recall our heat transfer to a substance, which is Q is equals to MC delta T. No, this should be a small t, yeah, capital T, change in temperature. Okay, where Q is the energy. Where Q is the energy, but we can convert this to power. Since we're given time. You know that power is the rate at which work is done. and so power is equals to Q over T. So since we don't have energy, therefore our Q is equals to power times time. So there we can have power times time equals to MC, change in temperature. But we don't have power as well. Okay, we don't have power as well. From your current and resistance equations, you must have come across V. Let me use a different. V is equals to I, R, the Ohm's law, and you must have come across power is equals to current times voltage. And when you combine these two equations, power is also equals to V squared over the resistance. So which means in this case, since we don't have power, we can substitute there with V squared over R. Okay, then simplifying this would be alright. Then now what you need is then to substitute. So our resistance, which is what we're looking for, will be equal to our voltage squared times our time, which is 25 minutes, but remember the SI unit is seconds, so divide that by the mass, 109, divide by C, which is 4,186, times the change in temperature, which is final minus initial, so it's going to be 49 minus 20. And then from this substitution, you can punch and see what we get. So there we are. Right, we get 6.53. So that's how you'd go about this kind of a question. So I hope you can follow the breakdown. This was the information provided. You're given voltage, you're given the mass, you're given the temperature change, and can then use your equation for heat transferred to a substance. Since we are given the specific capacity, the mass, and the change in temperature, which means it's possible to calculate the energy supplied. But you also know that energy times time will give you power. Energy times time will also give you power. But also remember that power is equals to V squared over resistance, which I've highlighted for you here. You must have some time come across these two equations, which reduce to the equation P is equals to V squared over R. So the rest becomes substitution. I hope that you are happy with this. I don't see any questions or comments so far. So we shall proceed to the next question. Question 13. Question 13 reads, two light bulbs both operate on 120 volts. One has a power of 25 watts and the other has 100 watts. Which light bulb has higher resistance? So can I throw it to you? I see there are people on Teams. Can I throw it to you to answer this one quickly in a minute? I'll give you a minute to think about it. Then you can type your answer in the chat, whether it's A, B, C, D, or E. So can I give you a minute to think about it? Once you've had a good thought about it, type your answer in the chat. So which of these two bulbs would have a higher resistance? I'll be looking forward to see your comments in the chat. Okay, 1 minute is up. What are your thoughts, Teams? What are your thoughts? I don't see any comment on the chat. I was hoping to find your answers by now. Which bulb would have the highest resistance? I see I've got a response on Yebo Physics YouTube channel. Someone responded there and they say it's bulb 1. How about those on Teams? What do you say? Okay, maybe you're shy to give your answer. So would help you by this equation. Remember the equation which we just presented earlier on? P is equals to V squared over the resistance. So in this case, the voltage is constant, meaning to say if you have to have a higher resistance, then the power would be low. Okay, so a low power will have a higher resistance. So which means that our correct answer would be bulb 1. So if you were thinking of bulb 1, and if you commented on bulb 1 on the YouTube chart, then that is correct. So if you want, you can actually do the computation to find what is the actual value of the resistance. You can calculate it, since you have got the voltage and the since you've got the voltage and the power. You can actually calculate to see what will be the magnitude of the resistances of these two bulbs, but that's not asked. We're supposed just to state which one has got a higher resistance. So let's move on to the next one. Question 14 reads, in the circuit below, assume that resistors and batteries are identical. Which circuit or circuits have the greatest energy delivered to them per second rather? So the first one, you have got So the first one, you've got two bulbs connected in series. You've got two bulbs connected in series, and you've got one power supply. Okay. Then the second one, you've got two batteries connected in parallel, which means the effective voltage across the bulbs would be that of a single battery. So voltage in parallel is always the same. Then on circuit 3, you can see that these two cells or battery cells are connected in series. So if this was 1,5, this would be 1,5. So it would be 3 volts across the bulbs. Whereas on second 2, if this was 1.5, the effective potential difference across the two bulbs will still be 1.5. Then here, obviously, you've got one cell, which means that across the potential difference across the two bulbs will still be 1.5 volts if each cell was 1.5. So which makes this cell to have the greatest energy delivered to them per second. So this one, because you've got 3 volts, so the potential difference would be 3 volts, assuming that one battery cell is 1.5 volts. So your correct answer there would be circuit 3. Okay, let's calculate electric cost. Question reads, what should be the bill for a month of June for a heater of resistance 60.5 ohms connected to 220 volt mains? Assume the cost of energy is at 2 rand per kilowatt hour and the heater is used 3 hours daily. So we're calculating electrical cost. So what we have, we've got a resistance 60.5 ohms. We've got a voltage of 220 volts. One kilowatt hour is equal to 2 rand, and the time is equals to 3 hours daily for 30 days. So the unit for electrical cost is kilowatt hour, which means it's your power in kilowatts times your time in hours. So so again, your power we're not given, but we can find our power given the resistance, given the voltage. We now know that power is equals to V squared over resistance. So V squared is going to be 220 squared over the resistance, which is 60.5. So I'm going to punch that quickly. That's 220 squared divided by 60.5, so you get 800 watts. But remember, we say the power should be in kilowatts, so that becomes 0.8 kilowatts. So we've divided by 1000, so that becomes 0.8 kilowatts times the time, which is 3 hours already, in hours, times 30 days. So you have to multiply your 3 hours by 30 days. So this will be 0.8 multiplied by 72. So this is, but we've been told that 1 kilowatt hour is 2 rand per kilowatt hour. So this cancels that. You remain with 72 times 2, which is 144. Rand. So you can see you've got an option for 144 rand that you have there. So that is essentially how you'd go about that calculation for determining the energy, the total energy used in kilowatt hour, then you then multiply by the cost per unit. Multiply by the cost per unit. Any questions? I don't see any, so we're going to move on. So we're now on question 16. So the question says, assuming the two resistors are identical, rank the currents at points 1, 2, 3, 4, 5, and 6 from highest to lowest. From highest to lowest. So how can we do that? From highest to lowest, so this is what we have. So this is 0.5, 0.6, 0.4, 0.3. Alright, so current flows from the positive to the negative. Conventional current rather. So current is going to get to that point, which we can say this is your I1, branches there to I2, and branches there to I3. Meaning to say I1 is equals to I2 plus I3. So there I3 and I2 combine at that junction. Combine at that junction to give I1. So which immediately answers our question to say the current flowing at this junction, not at the junction, the currents 5 and 6 are the same. Okay, currents 3 and 4 are the same, and current 1 and 2 are the same because it's in series. But which one is the greatest? The current from the battery. Okay, current from the battery, which then split into I2 and I3. But in both branches where I2 and I3 are flowing, there is one bulb, and the two bulbs, or the bulbs, have got the same resistances, which means I1, the current at 1, the current at 2, the current at 3, the current at 4 have got the same magnitude. So if we were to rank, 5 is equals to 6, followed by 1 equals to 2, equals to 3, equals to 4. So the current at those 4 points, 1, 2, 3, and 4 is the same. It is the same. And the current is highest at the point where current is leaving the battery cell to when it is returning. I hope you are happy with that. All right, so I want to throw this to you to have a look at it. So it's also about the flow of current, and take it like a nice exercise that you can try and work it out, see if you can open this circuit to see what is the equivalent of this circuit, right? Just for critical thinking, it will be a good question to try out on your own, just to see if you can reproduce this circuit in terms of replacing with real light bulbs. Some of you are engineers into electrical engineering, some of you are into pure science, so this should be something that would be interesting for you to try out on your own. And obviously, if you find it not making sense, you can always give a shout out. So I'm leaving this to you, and I'm also leaving question 18 to you. It's just a conceptual question, just to check if you understand the term or definition of potential difference. Then question 19 is asking which of the following graph represents an ohmic conductor. Again, I'll not choose the option for you, but you can have a look. These are the conductors that you have here. Which one would suit an ohmic conductor? Remember ohmic from Ohm's law, which is V is equals to IR. V equals to IR. So already there is a hint there. Already, so you're looking for the one that has got a linear relationship. So that's a linear equation. No intercept. You can see it's cutting at the origin. So I'll leave this to you as well. You can then follow up and look. And the last question we would work out together is on resistance. I'm already showing the question, so you can have a look at it. So the question reads, two resistors are connected in A, in series, B, in parallel. The equivalent resistance in the two cases are 9 ohm and 12 ohm respectively. What is the resistance of the component resistors? So there's an error on that question. Instead of 12 ohms, that should have been 2 ohms. So I had to check that carefully when I was preparing for the tutorial. I think we'll flag it to the lecturer to correct that. So that should be 9 ohms and 12 ohms. 9 ohms and 2 ohms. Otherwise, if you work it with 9 ohm and 12 ohms, you will not get any of the combination shown there. So how would you go about this question? So you've got a series connection, R1 plus R2 is equal to 9. That becomes your first equation. Then 1 over R1 plus 1 over R2 is equals to 2. It will be 1 over 2, right? It will be 1 over 2. Why? Because remember 1 over R1 plus 1 over R2 is equals to 1 over R total. So common denominator R1 plus R. No, what am I doing? If you are to add that, so you're just combining that. If you cross multiply or invert, then you have R1, R2 over R2 or R1 plus R2 equals to 2. Just invert. So this becomes our second equation. So now you can solve these two simultaneous equations. Okay. R1 plus R2 is equals to 9 from this equation. R1 plus R2 is equals to 9. Therefore, your R1, R2 is equals to, put a 9 there, equals to 2. So which means R1, R2 is equals to 18. So if you simplify, you can have your R1 being equal to 18 over R2. Then you can substitute into equation 1, where we said R1 plus R2 is equals to 9. Then in place of R1, we've got 18 over R2 plus R2 equals to 9. Then if you have to multiply by R2, both sides, then this becomes 18 plus R2 squared equals to 9R squared, 9R2, sorry. So which means you now have R squared minus 9R2 plus 18 equals to 0. So you see you've got a quadratic equation which you have there. So you can find, depending on how you prefer to work it out, to simplify this quadratic, you can either find two factors that you add to give you negative 9, which you multiply and they give you 18. So I'll then go for minus 6R minus 3R plus 18 equals to 0. If you add this minus that, and it will still give you negative 9R. Then you can factor out R2. R2 becomes R2 minus 6. Then you have the minus R, minus 3R, minus 3 rather. Alright, so which means that from this your R2 So R2 is equals to 6, or R2 is equals to 3. So R2 can either be 3 or it can either be 6. But what is R1? Okay. So if R2 is equals to 6, then using R1 plus R2 equals to 9. What will be R1? R1 will be equals to 9 minus R2. So if R2 is 6, then R1 would be equals to 3 ohms. Then if R2 is equals to 3 ohms, because we said R2 can either be 6 or 3, therefore R1 would be equal to 9 minus R2, so becomes 9 minus 3, which is going to be 6 ohms. So R1 can also either be 3 ohms or 6 ohms. So that is how you'd go about this question. So it's just a matter of forming forming simultaneous equations and then solving them. So the maths, how you solve them, it's all up to you, what you prefer. But this is how you'd go about that problem. Okay. Are there any questions? Are there any questions or comments from what we have looked at? So these are the questions, few questions on current and resistance, just to check on your understanding of current and resistance calculations. So more problems on circuits will be solved in the next tutorial. So be sure to join in tomorrow. There's going to be a tutorial Friday afternoon. So be sure to check your emails for the invite. And likewise, wish you all the best. And should you have challenges whilst you're preparing, feel free to reach out to any of the tutors. We'll be very glad to assist. So from me and the rest of the team in the studio, it's a goodbye.